All right, let's jump right in. Today, we're going to tackle one of the most crucial skills in all of web development. We're talking about how to make a form on a web page actually talk to your server. This, right here, is the magic that turns a simple, static page into a living, breathing application.
And trust me, that is no exaggeration. What we're covering today isn't just another lab exercise. It's the absolute bedrock of your entire career as a software developer. Mastering this connection, it's completely non-negotiable for building anything in the real world.
So, let's start at the very beginning. Every single time you interact with the web, you're kicking off this invisible conversation between your browser, that's the client, and a server that could be anywhere in the world. A simple click from you can set off a whole cascade of events.
Seriously, think about it. Logging into your favorite site, buying a new pair of sneakers online, updating your profile picture, all of these actions are powered by something we call API endpoints. You can just think of them as specific addresses on a server, totally designed to handle these exact kinds of requests. You're not just coding, you're building the very engine of the modern web, and it all starts with a simple form.
And the number one tool for the job is the good old HTML form. It's really just a bridge that lets a user package up some information, like a username or a search query, and send it flying across the internet to a server that knows exactly what to do with it.
Now, what I love about this is how it shows you the whole journey. So, a user types something into a form, the browser then neatly packages that data up and sends a request to a very specific server endpoint. And how does it know where to send it? Well, that's defined in the HTML form's action attribute. It's literally the mailing address for that data. This is that fundamental handoff from client to server.
Okay, so to send that data, we've got two main ways to do it. First up is GET. The easiest way to think of GET is like the read-only mode for the web. You're asking the server for information, but you're making a promise. Hey, I'm not going to change anything.
In this library analogy, it is perfect. When you make a GET request, you're just looking around. You can browse the card catalog, you can read any book you want, but you can't add new books or scribble in the margins. You're just a passive observer taking in information.
So, the crucial point here is that GET requests are all about retrieval. And mechanically, the way they do this is by tacking the data right onto the end of the URL as what we call query parameters. I guarantee you've seen this a million times in your Google search results.
And this leads to some really key traits. First, the data is visible right there in the URL, which means you should never send passwords or sensitive stuff this way. There's also a character limit, and it's what we call safe and idempotent, which is a fancy way of saying you can refresh the page or click the link 100 times and it won't break anything or change anything on the server. Because of all that, it's also cacheable, which is awesome for performance.
Okay, so now let's talk about the other side of the coin, the POST request. If GET is for reading the web, well, POST is for writing to it. It's how you actually change things, create new data, and alter the state of an application.
Let's go back to our library. A POST request is an active, meaningful change. You're not just browsing anymore. Now you're adding a brand new book to the shelf, you're updating your contact info on your library card, or you're reserving a room. These are actions that have real consequences.
And here's the huge mechanical difference. POST sends its data tucked away inside the request body, totally hidden from the user's view. It's not part of the URL at all. This makes it absolutely perfect for sending sensitive information or just a lot of data.
So let's compare POST to GET. The data is hidden, and there are pretty much no size limits. It is not safe because its whole purpose is to change things on the server, and it's not idempotent. Think about it. If you submit a purchase form twice, you're probably going to buy 2 items, right? And for all those reasons, it's not cacheable. Choosing between GET and POST isn't just some minor technical detail. It's about following let's call it the semantic philosophy of the web. It's all about using the right tool for the job. And when you do that, your applications become way more predictable, efficient, and secure.
This side-by-side view really boils it all down. Here's a way to think about it. A GET request is like asking a question out loud in a public library. Everybody can hear it, and you're not really changing anything. A POST request, that's like slipping a sealed, private envelope to the librarian. It's confidential, and it's meant to kick off some kind of action.
And if we kind of zoom out, you can see how these methods fit into a bigger picture called CRUD. It stands for the 4 basic things you can do with data: create, read, update, and delete. As you can see, GET handles the read, and POST handles the create. Later on, you'll meet put and delete, which handle the rest, and that completes the whole set of actions you need to manage data in basically any application.
So, this is the point where you might be asking yourself, okay, I get it, but
why does this distinction actually matter in the real world? What really breaks if I get this wrong?
Well, here's the thing. Using these methods correctly, according to a design philosophy called REST, has massive benefits. REST is just a set of rules for making websites that are predictable and reliable. Following these rules allows browsers to cache your pages for lightning speed, it lets search engines like Google crawl your site without accidentally deleting all your data, and it prevents that classic mistake of a simple page refresh buying something twice. It's huge. And I absolutely love this quote. Getting this right is the difference between just hacking something together that kinda sorta works and truly engineering a system that's robust, scalable, and professional. This right here is a hallmark of a great developer.
So now, let's connect all these ideas to our ultimate goal, building large-scale, enterprise-grade applications. Because, believe it or not, it all starts right here.
Seriously, whether you're talking about a banking platform, a giant e-commerce site, or a complex inventory system, at their very core, they all rely on the same foundation. That simple form you're building in the lab is the tiny seed for the massive systems that run global businesses. The principles of GET and POST are what developers use every single day to make it all tick.
And this diagram just brings it all together. It's the full cycle. An HTML form collects user input, let's say your favorite ice cream flavor. It sends that data in a POST request to an Express server. The server then uses a templating engine to create a custom HTML page on the fly, one that says, hey, you like chocolate chip, and sends that page right back to the user's browser. It's a complete call and response loop.
And this is just the beginning. Now here's a pro tip. To test these server endpoints directly, without even needing a browser, developers use a tool called Postman. It lets you build your own custom requests and see the raw response from the server, which is an absolute lifesaver for debugging. As you build out your ice cream shop app, you'll use it to test every single piece of the puzzle. So as you move forward, I want you to burn these 3 questions into your mind. They are your North Star for debugging and for understanding the flow of pretty much any web application out there. If you can always answer these 3 questions, you can build anything.